To be able to demonstrate and understand what happens during a chemical reaction, it is essential to grasp the concept of chemical equations. One basic way to represent a reaction is by using a word equation. For example, imagine we are told that methane reacts with oxygen, and the result of this reaction is the formation of carbon dioxide and water. In the word equation, we write the substances that take part in the reaction on the left-hand side. These are known as the reactants. In this case, the reactants are methane and oxygen. On the right-hand side, we write the substances that are produced during the reaction. These are called the products, which, in our example, are carbon dioxide and water. Between the reactants and products, we place a single arrow which points from left to right to show that the reactants have reacted completely to form the products. While word equations help describe what is happening, it is much more common and useful in chemistry to use symbol equations. Symbol equations use the actual chemical symbols and formulas of the substances involved in the reaction. For instance, we would write CH4 plus O2 to represent methane and oxygen reacting. This produces CO2 and H2O, which are carbon dioxide and water. You may notice that oxygen is written as O2 instead of just O. This is because in nature oxygen exists as a diatomic molecule, which means that two oxygen atoms are always bonded together. Similarly, chlorine is written as Cl2 and nitrogen is written as N2 for the same reason. Now, if we take a closer look at our symbol equation, we might notice that it is not quite correct just yet because it is not balanced. A balanced chemical equation must have the same total number of atoms of each element on both sides of the arrow. Let us count. On the left side, we have 1 carbon atom, 4 hydrogen atoms, and 2 oxygen atoms. On the right side, we have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. Clearly, the numbers do not match, so our equation is unbalanced. Our goal now is to adjust the equation so that we have equal numbers of each type of atom on both sides. Balancing equations is often done by trial and error, where we try different numbers until the atom counts match. The first and most important rule in balancing equations is that we are not allowed to change any of the small numbers that are written within the chemical formulas. These small numbers represent the structure of the molecule, and changing them would change the identity of the substance itself. For example, we cannot change O2 to O3 because O3 is a completely different molecule known as ozone and not oxygen gas. Instead, what we can do is change the large numbers placed in front of the chemical formulas. These large numbers tell us how many molecules or moles of that substance are involved. So to increase the number of oxygen atoms on the left-hand side, we can place a 2 in front of the O2. This means we now have 2 molecules of oxygen gas, which gives us a total of 4 oxygen atoms. Although we only need 3 oxygen atoms to match the right side of the equation, we are not allowed to use decimal or fraction values like 1.5 molecules. Chemical equations must always use whole numbers, so we round up to 2 oxygen molecules, giving 4 oxygen atoms in total. Now we turn our attention to the right side. We need to increase the number of hydrogen atoms and balance the oxygen atoms as well. To do this, we can change the number of water molecules from 1 to 2. Each water molecule contains 2 hydrogen atoms and 1 oxygen atom, so 2 water molecules give us 4 hydrogen atoms and 2 oxygen atoms. Combined with the 1 oxygen atom from carbon dioxide, we now have 3 oxygen atoms on the right side. Wait, but we had placed 2 O2 molecules on the left side, which give 4 oxygen atoms. We must check and recheck until both sides have equal numbers. After making these adjustments, we find that the numbers finally match. We now have 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms on each side of the equation, which means the equation is balanced. Let us now try another example involving sulfuric acid and sodium hydroxide. In this reaction, sulfuric acid reacts with sodium hydroxide to produce sodium sulfate and water. First, we write the unbalanced equation. On the left, we have sulfuric acid and sodium hydroxide. On the right, we have sodium sulfate and water. If we count the atoms, we see that we have 3 hydrogen atoms, 1 sulfur atom, 5 oxygen atoms, and 1 sodium atom on the left side. On the right side, we have 2 hydrogen atoms, 1 sulfur atom, 5 oxygen atoms, and 2 sodium atoms. Clearly, the sodium atoms are not balanced. A good strategy when balancing equations is to start with the elements that appear the fewest number of times. In this case, sulfur appears only once on each side and is already balanced. So we focus on sodium next. The right side has 2 sodium atoms, while the left side only has 1. To balance sodium, we place a 2 in front of the sodium hydroxide on the left. This gives us 2 sodium atoms and also increases the number of hydrogen and oxygen atoms. Now we count the atoms again. On the left side, we now have 4 hydrogen atoms, 1 sulfur atom, 6 oxygen atoms, and 2 sodium atoms. On the right, we have 2 hydrogen atoms in 1 water molecule, and we need 2 more hydrogens and 1 more oxygen to match the left. We can fix this by adding 1 more water molecule to the right, giving us 2 water molecules. Now we have 4 hydrogen atoms and 2 oxygen atoms from water, plus the remaining atoms from sodium sulfate. Finally, we double-check. On both sides, we now have 4 hydrogen atoms, 1 sulfur atom, 6 oxygen atoms, and 2 sodium atoms. The equation is fully balanced. This step of reviewing and confirming your atom counts is critical to ensure your answer is complete and accurate. Balancing chemical equations takes practice, but by following these rules using whole numbers and adjusting only the large coefficients, you can become confident in representing chemical reactions correctly. That concludes this explanation on chemical equations and balancing them. I hope you found it helpful and informative, and we will see you again in the next lesson.